first of all, I will need to understand what are the deviations and how we move into that particular area. ठीक है, तो rods का हमारे पास क्या है, ध्यान समझिएगा इस चीज को. You don't need to write everything. Rather, you don't need to write anything right now. Leave your pen aside. When I say leave your pen, just leave it and look at the screen, try to understand. Rod's law says that P total of a solution of two volatile liquids will be equal to P naught A into phi A plus P naught B into phi B. Assalamu alaikum, Mariam. Am I audible? Mariam, am I audible?
Yes, sir.
Yes, Mariam. Why are you late, Mariam?
Sleeping.
नहीं तो टाइम का ख्याल रखें, है ना?
Sorry, sir.
टाइम का ख्याल रखिए, टाइम का.
Yes, sir.
So we were talking about Rod's law, and Rod's law says that P total will be equal to P naught A phi A plus P naught B phi B. Now let us try to imagine ourselves in a laboratory. You don't need to write into here. Okay, कुछ नहीं लिखना आपको, आराम से मिले. Now in a laboratory, what we can do, we can take, let us suppose, ethanol, and we will take water. Okay. Now the P naught of ethanol, that means the vapor pressure of ethanol in its pure form, that data, let's suppose this is A, ये आपके पास A और ये आपके पास B. So P naught of the ethanol will be available in the data. Like if you Google what is the vapor pressure of ethanol at 25 degrees Celsius, that data will be available because many of the people have already done the experiment. Similarly, the P naught B will be available. Makes sense? इसमें भी चल. बात समझ में आ रही है यहाँ तक? हाँ या ना बताएं. The vapor pressure of pure ethanol, the vapor pressure of water will be known. Makes sense? Amna and Ansha. It's like boiling point, ना? Boiling point of water सबको पता है. Like property of pure something would be easily known. ठीक है, एक बार एक्सपेरिमेंट होते हैं, उसके बाद फिर वो डेटा as a standard it is being used. Makes sense? So I need yes sir, no sir from everyone. This is very important to understand.
Yes,
Yes,
sir.
Mariam, Amna and Ansha.
Yes, sir.
Yes. Now, similarly, it's up to you how much ethanol you want to take and how much water you want to take. Okay. So, in a sense, this is already known. And how much mole fraction of A you want to take and what will be the mole fraction of B that you want to take. You don't need to really take it. You can just do the calculations and get the mole fraction of A and fraction of B. Does that make sense? I know the chi A and chi B also. Makes sense?
Yes, sir.
Right? All of you guys are with me till here. Mariam, Amna, tell me.
Yes, sir.
Okay, so P naught is known, chi A is known, P naught B is known, and chi B is also. Now, if all of these things are known, we don't need to really do any experiment. We can just plug in the values, and we can get the P total, vapor pressure of the solution. And we have been doing the numericals such that we have been doing those type of numericals, yes or no? Make sense?
Yes.
Okay, now we will use this whole equation and we will get a P total, and we will see that this P total, it is what? If this P total is P calculated. We have not done any experiment. We have calculated this pressure. Another thing, what we can really do, and we can do an experiment. What we will do, let's suppose we have container. In this we have plug-in. Here we have ethanol, and here we have water, and here we have somehow measured the pressure. Now this pressure that we have measured, this will be the P experimental. Does that make sense? Tell me. Same amount, and we have taken, I mean, whatever thought we thought, like we will take this much chi A and this much chi B, the same amount we took, and we have got some pressure, that is the pressure that will be experimental. That is also the total pressure, but that total pressure is experimental. Make sense? Yes or no? Amna, Insha, and Mariam.
Yes, sir.
आमना, आपकी आवाज नहीं आ रही. आमना, are you there? Yes sir, no sir, कुछ तो बोलिएगा ना आमना.
Yes, sir.
You understand? Are you understanding it here?
Yes.
See, now please see. We have got P calculated and P experiment. Now there are only two possibilities from here. Either the P calculated will be equal to P experimental, or what would happen? The P experimental and the P calculated will not be equal. Will not be equal. There are only two cases which possibilities दो हैं. क्या होगा नहीं होगा वो भी नहीं पता, but there are two possibilities. एक चीज आपने कैलकुलेट किया, one thing is experimental. So this P calculated will not be equal to P experimental. Okay. Now when a solution, when the P calculated and P experimental of the solution are equal, then we say that that solution is following the Rawls law, because using the Rawls law you can determine the total pressure
Pressure.
experiment. Make sense?
Yes, sir.
You're asking something. Okay. And similarly, if there is a solution in which P calculated is not equal to P experimental, we will say that that does not follow the Rawls law. And the solution which follows the Rawls law, we call it ideal solution. The one which does not follow, we call it non-ideal solution. अब यहाँ पे भी ना P calculated में अब दो बात हो सकते हैं.
Sir, your voice is breaking a lot. I can barely hear anything.
What about others? Amna and Mariam, am I audible?
No, sir. It's the same for me.
जोर से बोलिए जरा.
Sir, your voice is not clear at all.
Is it not clear right now, or it has not been clear throughout the class? Is it clear initially? Guys, am I audible now, or am I not audible now? Am I audible, guys? Am I audible? Am I audible now, guys? Hello? अभी clear? Amna, Ishan, Mariam? That one.
No, sir.
Now, is it audible now? Is it audible now? Hello? Guys, बताइए, am I audible now? Chat पे मत बताइएगा, या mic on कर बताइएगा.
Hello.
Yes, hello. It's low. Okay, fine, fine. It's low. देखते हैं कुछ. I think now it will be very clear. Is it clear now?
Sir, can you speak again something?
No, sir, it's
I
not
don't know
clear
why
yet.
I can't understand.
No, no, sir, it's not clear.
Still breaking?
Yes, sir, a lot.
How about now? Am I audible?
No, sir, it's not. Your voice is not coming.
Why is it?
No, sir, it's still the same.
Hello, sir, can you say something?
Your voice is breaking. I'm saying this thing.
Can you hear Mario?
No, sir, no, Incha, not for me. It's very unclear.
Me neither. I can't understand anything.
I first thought it's just my internet, but I think it's not.
Fine. I will just read.
Eh,
Are you saying something?
did the sir say anything and leave?
I think we'll reconnect. Yeah.
Mhm.
Hello. Am I audible now? Wait,
Can you say something a bit longer?
ideal selection follows Rod's law over the entire range of solutions. Non-ideal solution does not follow Rod's law over the entire range
So
of
now it's okay.
No, no, no. It's very loud. No, no, wait.
I say it's
So can you
loud,
say
but I
something
can
again?
it,
It's breaking again.
Sir, it's the same.
Hello.
Can you hear us?
Yeah, I can hear you.
Yeah, I can hear you too.
Completely fine. Mariam? Mariam, can you hear me, Mariam?
Yes, sir, it's fine now.
Just- Did you guys understand anything that I was speaking?
Can you repeat?
What the P calculated and P experimental? Did you understand anything?
Tell me guys. Am I not audible again here? Yes or no तो बता सकते हैं आप लोग. Am I audible? Hello, Amna, Inshan, Mariam.
Sir, now you're audible.
So I was
But
asking.
नहीं, बीच में चली गई थी.
अच्छा, now I'm audible ना? I was asking.
Yes.
Did you understand everything that I taught till now about P calculated and P experimental?
Yes. Yes.
Mariam.
Sir, can you explain P calculated again?
P calculated is just imagine you want to mix ethanol and water. So you would know what is the P naught of ethanol and what is the P naught of water because those data will be readily available as boiling point. It's a boiling point of water, it's readily known. Boiling point of ethanol or boiling point of any liquid will be known. So property of a certain pure liquid will be always known. For example, P naught, the vapor pressure. Many people would have done experiment and calculated the vapor pressure of a solvent or any liquid. So P naught A, P naught B is known. The amount of ethanol that you want to take and the amount of water that you want to take, that is up to you. So you already know the chi A and chi B also. So without even doing any experiment, what we can do, we can determine the pressure, the total pressure when we mix ethanol and water. That is the P calculated without doing any experiment. That we calculate, that is the P calculated. Make sense, Mariam?
Yes, understood, sir.
Okay. Now, then what we do, we mix them really. Like ethanol itna liya, water itna liya, and then we mix them. Once we mix them, then we measure rather, then we measure the pressure. That pressure which is measured, it is the P experimental. Make sense, Jasola, please tell me.
Yes, sir.
Now there are two possibilities. P calculated will be either equal to P experimental or P calculated will not be equal. When the P calculated is equal to the P experimental, then we will say, okay, fine, this solution, it is following the Raoult's law. That means we can use the Raoult's law in order to calculate the P total. We don't need to do the experiment. I hope you understand that experimentation is very expensive. That you need to get ethanol, you need to get water, then you need to get all the instrument to measure the pressure and everything. You need to have a weighing some scale, weighing scale, so that you can measure the amount of ethanol, you can measure the amount of water, right? So experimentations are very tough. That is why we get formulas. Formula. So why this formula? So this Raoult's law, it is giving you something that you can only have with experiments. Now with Raoult's law, you can get the total pressure without the experiment also. So that is the benefit of theory and that is the benefit of formulas. Okay. Moving on, we will move on to the topic that is ideal solution, non-ideal solution, deviations in Raoult's law. Okay. अभी पहले लिखेंगे हम लोग ideal solution and non-ideal solution. Right, Devani? You have got the gist, so I will just keep writing and hopefully you will be understanding each and every line. Ideal solution and non-ideal solution. ठीक है, इसमें से पहले लिखिएगा. Ideal solution. What is ideal solution? It will follows Raoult's law over entire range of concentration. And that means it is going to always follow the Raoult's law. Now in this case, P experimental बोली चाहे कभी-कभी इसको P observed भी बोला जाता है. P observed is equal to the P calculated. Therefore, the difference between these two, delta P, that is the P observed minus P calculated. ठीक है? This will be equal to 0 because both of these things are going to be equal. ठीक है? Now, what leads to this type of solution? What leads to the ideal solution? When the interaction between solvent molecules and the interaction between the solute molecules, okay, they are same. So when we have intermolecular forces of attraction between A and B, if they are similar, so when you mix them, like the way A interacts with A is very similar to how A is interacting with B. That is why what's going to happen. That is why the vapors are going to be similar. ठीक है? यहाँ पे आप लिखिएगा point liquids with similar intermolecular force of इसको हम पूरा लिख देते हैं intermolecular force of attraction. IMF, है ना? We will sometimes use this abbreviation. Form ideal solution. Example: benzene and toluene. Now, benzene and toluene, they have similar structure. Both of them are what? Non-polar. Okay, they are not polar. That is why they form ideal solution. Similarly, N-hexane and N-15. N का मतलब होता है normal. That means you will have like this, है ना? There are no branches. N का मतलब you will not be having any branch. Now again, both of these are also non-polar. Then you have a polar example, chloroethane and bromoethane. Both of these are polar. Chloroethane is also polar and bromethane is also polar. Once you mix them, then also you will be having dipole-dipole interaction. Done writing? Raise your hand if you're done writing. Now, in this case, the examples are also important. Okay. Examples, this particular topic, it is one of the favorite topic of CBCE. And like there is one question from this particular topic always. Okay, so if you are most of the people what they think when they hear about solution, it is numerical, but this is one of those topics that is completely theoretical. It is quite easy also, and CBSE will ask the question at least one question always from this particular topic. Whatever we are going to cover in today's like the whole class. आज की क्लास से एक मार्क्स तो आपको पता है like आज की क्लास से ठीक है. Then Insha, okay, Insha is waiting for Amna and Mariam. बाकी बच्चे आज क्यों नहीं आए हैं? Waiting for Amna now. आवाज साफ है बिल्कुल इंशा एंड मरियम?
जी सर.
जी सर.
आमना वेटिंग फॉर यू. आमना जल्दी लिखिए. आमना सो गए क्या आप? आमना यार not really engaging in the class anymore. Yes, आमना. ठीक. Next, we will write the characteristics of ideal solution. Characteristics of ideal solution. Now, in this first one is the enthalpy of mixing. Now, since neither there is any attraction between the solute and solvent particles, नहीं attraction बढ़ रहा है, nor there is any repulsion. If there was attraction, then solute and solvent particles would be readily interacting with each other and they will be dissolving very easily. है ना? Now, I mean, they will be dissolving readily, not easily, rather readily. वो चाह रहे हैं कि हम dissolve हो जाए. In that case, the energy would be released. Now, if the solute and solvent molecules they are repelling each other, then you will have to put energy in order to mix them. But in the case of ideal solution, the behaving in their pure form is the same way they are behaving in their mixture form. That is why the delta H mix is equal to 0. There is no change. Similarly, the delta V mix. Like, is there any change? If I take 100 ml of water, 100 ml of ethanol, will I get slightly? We can get slightly greater volume if the ethanol and water molecules are repelling each other. And if they are repelling each other, then the volume will increase. If they are attracting each other, the volume will shrink. But in this case, nothing is happening. That is why the delta V mix will also be equal to 0. Then third is delta G. Delta G mix for this case will be equal to negative. Why? Because entropy to increase. Whenever you mix something, the entropy increases. And because H is 0, it will completely depend on entropy now. So fourth है आपके पास delta S mix. Entropy of mixing. So whenever there is an increase in volume, generally वहाँ पे entropy बढ़ती है, ठीक है? तो delta S mix will be positive. Delta S mix will be positive for ideal solution. Please इसको copy कर लीजिए. Like इस portion से बहुत सवाल आए. Like in the JEE and NEET also, they have been asking what this particular these things, these properties and these characteristics. Delta G mix is negative. That is why it is a spontaneous process. I mean, that means if you don't have to put in energy somewhere, that will be spontaneous, right? So delta G is what? It is negative. Drop it down. Raise your hand once you're done.
Sir, what is delta S mix?
Entropy. You remember entropy from thermodynamics?
Yes.
That is. You must have seen whenever volume increases, like liquid melts. Ice melts. That is entropy increases. Liquid vaporizes, then also entropy increases. So whenever there is something which is expanding, है ना, तो वहां पे आप समझ लीजिए कि एंट्रोपी बढ़ रही है. Waiting for Amna and Mariam. जल्दी लिखिए. I think this should be done quickly. Just waiting for Amna. Amna पेन जल्दी चलाइए आप. मेहंदी लगा रहे हैं क्या? पेन चलाइए पेन. ठीक है. कुछ बच्चे लिखते हैं बिल्कुल इस तरह से जैसे मेहंदी लगा रहे हो. लिखिए आप लोग नेक्स्ट नॉन आइडियल सोल्यूशन. Right here. Do not follow. God's law over entire range of concentration. Over entire range of concentration. Now, in this, we have already seen the pressure that is observed, जो कि experimental है, that is not equal to the pressure which is calculated from the Rolls law. ठीक है? That means if I talk about the del P, that means the error है ना? Error P में कितना आ रहा है? So it will be P observed minus P calculated, and this will not be equal to 0. It will be having some value. अब not be equal to 0 में हम आ जाते हैं types of non-ideal solution के ऊपर. Not equal to 0 में there will be two cases. Either it will be greater than 0 or less than 0. ना, और P observed क्या हो सकता है? ज्यादा हो सकता है, कम भी हो सकता है. ठीक है. So now we are moving on to the topic. Non-ideal नहीं है, but topic जो है आपका एक नया सब टॉपिक के हिसाब से लिख सकते हैं. Types of non-ideal solution. ठीक है, ध्यान दीजिएगा. ठीक है. इफ यू आर नॉट डन राइटिंग डोंट वरी. ठीक है, हम आपको टाइम दे देंगे. अभी बस आप कुछ सुनिए. ठीक है ना. लीव योर पेन साइड. जहाँ तक लिखा आपने वहां तक ठीक है. कुछ नहीं लिखा कोई बात नहीं. ठीक है, आराम से सुनिए. देयर विल बी टू डिफरेंट केसेस. एक आपके पास केस होगा इन विच द पी ऑब्जर्व विल बी ग्रेटर देन पी कैलकुलेटेड एंड वी कॉल दिस पॉजिटिव डेविएशन. है ना, बिकॉज डेल पी जो आएगा ना वो पॉजिटिव आएगा. तो देखिए, पी इफ पी ऑब्जर्व इज ग्रेटर देन पी कैलकुलेटेड देन द एरर और द डिफरेंस इन द प्रेशर विल बी पॉजिटिव. है ना, वो पॉजिटिव नंबर आएगा. दैट इज लाइक because in this case del p is equal to positive, इसको कहा जाता है पॉजिटिव डेविएशन. दिस डेविएशन इज नोन एज पॉजिटिव डेविएशन. Similarly, the other case would be when the p observed it is less than the p calculated. In this case, if I calculate the del p, it will be negative, and this is known as negative deviation. This is known as negative deviation. अच्छा, अब थोड़ा हम लोग समझते हैं कि ये पॉजिटिव डेविएशन हो क्यों रहा है, and we want to understand the in terms of intermolecular forces of attraction. So please be with me and try to turn your mic on. ठीक है, and you have to answer a few things. फिर आप खुद समझ में आ जाएंगी चीजें. Tell me, uh, if P observed is greater than P calculated, that means we are having more vapors, we are having more pressure than expected. Make sense, guys? Yes or no? We are having more pressure than expected.
Yes.
इंशा मरियम जवाब दीजिएगा तब आप समझ में आएगी चीज अच्छे से. ठीक है, वरना फिर रटते रह जाइएगा. जी बताएं. मेक सेंस ना? प्रेशर इज मोर देन एक्सपेक्टेड. हाँ या ना?
Yes.
Keep your mic on. Keep your mic on. Don't turn it off. Okay, please don't turn it off. Pressure is greater than expected. That means there is more vapors than expected. जो vapor
Yes.
molecules है, there will be more vapors than expected.
Yes.
Now, if more vapors are present, that means escaping tendency has increased.
Yes.
Solute
Yes.
and solvent molecules, they don't want to stay together in the solution. They are running away from the solution. Make sense?
Yes.
Correct? That is only possible if the solute and solvent molecules are having bad interaction. If they had good interaction, if they were interacting, if they were attracted with each other, both solute and solvent molecules will be inside the solution. Okay. So what is happening right now? We are having more vapors. Why there will be more vapors? There will be more vapors only if the solute and solvent molecules they are not having good interaction. Make sense? Yes or no? Please tell me.
Yes, sir.
Yes.
Okay. I'm writing. You don't write. Okay. That means we
Okay.
have bad interaction. Bad interaction between A and B. What is A and B? A is solvent and solute. Okay. Now, if A and B are having bad interaction, that means we will have to give some energy in order to mix them. We have to stir it or we have to mix it. Like mixer में mix करना पड़ सकता है. Make sense? Yes or no? We have to
Yes.
give in some energy, right, to mix them. So delta H will be what? Delta H of mixing, it will be positive. That means we are giving energy in the system. The system की energy बढ़ रही है. That is why positive. Another thing is that delta V mix. Now, when we are having A and B, which are not interacting with each other, they are repelling. So when they are repelling each other, they will be occupying more space also. Make sense? Yes or no? Please tell me. Delta V mix
Can
समझ
you
में आया?
explain again?
Yes, sir.
If A and B are far away from each other, they are repelling each other. No? So they will be far away. So they will be occupying more space. No?
Yes.
So that is why the volume will increase after mixing. Like if you are mixing 100 ml and 100 ml, so you are expecting the solution to be 200 ml. But after mixing, they are repelling each other. So the solution will be 210 ml or 213 ml, 205 ml. Make sense?
Okay.
Okay. Next thing is
Yes.
that we have also known that when the vapor pressure and boiling point are inversely proportional. So since vapor pressure has increased, that we have written, the boiling point will be lowered in this case. If this boiling point is lowered, we are going to use this in the next topic. Okay, boiling point will be lowered. Now the opposite happens in the next case. When the P observed is less, that means we are having less vapors. Less vapors will be present only and only if the solute and solvent molecules, they are having good interaction between them. They are attracted to each other. And when they are attracted to each other, the solute molecules will not let the solvent molecules escape out. Neither the solvent molecules will let the solute molecules escape out. And that is why what happens, less vapors is present, and that is why we are having less vapor pressure also. Hence, we can say here that we are having good interaction between A and B. Next, we can talk about the delta H mix. Now, since there is attraction between the solute and solvent molecules, the energy will release. As soon as they are mixing, they will release energy and this will be negative. And similarly, the delta V mix will also be negative because they will be occupying less volume than expected because they are attracted to each other. And when they are attracted, they will be closer. When they are closer, they will be occupying less volume. And since the vapor pressure is inversely proportional to the boiling point, in this case, the boiling point will be increased. The boiling point increased. I will write like this. Boiling point will be lowered. Will be increased. Does this make sense? Here? This whole thing
Yes,
makes
sir.
sense? Please stop it now. If you think about memorizing this also, the memorization part is also quite easy because positive is something positive and negative is something negative. Right? Important things are delta H mix and delta V mix for the board examination. These are the okay. Please write this down. अच्छा इस पर examples दिखाना था. Actually फिर इस पर हम examples दिखा देंगे. Raise your hand once for writing. Waiting for Amna. Just below this, we will write some examples also. See, these examples are also important. ये ना ऐसे ही पूछ दिया जाता है examples. ठीक है. So I will be writing some examples. For positive deviation, you have ethanol and water. Ethanol and water. And और positive deviation में कौन है उसके पास? Ethanol and cyclohexane. ठीक है. Ethanol and acetone. Ethanol plus acetone. You know the structure of acetone? Amna, Insha, and Mariam, do you guys know what is the structure of acetone? ये पता आप लोग को?
Yes.
Sorry.
Yes, sir.
So that's ठीक है, fine. Similarly, in this example,
C double bond O.
sorry, what? बोलिए.
C double bond O.
बस C double bond हो इतना ही.
And
नहीं.
नहीं 2CH3.
हाँ, CH3 सर जी. So next we have chloroform. Chloroform का जो structure, the formula of chloroform is CHCl3. Okay? Chloroform has this particular CHCl3 and plus acetone. Okay? And this is the most important one. दूसरा एक important water and nitric acid. H2O plus HNO3. This is also important. एक दो बार ये शायद नीट में पूछा जाता है water और nitric acid के बारे में. And water HCl is there, chloroform nitric acid. Chloroform nitric acid is okay. HCl3 plus nitric acid HNO3. What else? And only have CHCl3 plus benzene here, that is C6H6. Okay. So these are some examples. We will study these two examples: ethanol acetone and chloroform acetone. Please write this down. Raise your hand once you're done. Just waiting for Amna. Done, Amna?
Yes, sir.
एक हमारे पास एग्जांपल है जो कि समझना है हम लोग को. Quite easy example. That is ethanol plus acetone. Ethanol plus acetone. Now what happens here? So ethanol has hydrogen bonding. Okay, so when ethanol molecules are on their own, then what will happen? The pure ethanol molecules, they will be having hydrogen bond between them. Now, what happens on acetone? On adding acetone, you will write as hydrogen bond. On adding acetone, the acetone molecules come in between the ethanol molecules Now, when they will come between the ethanol molecules, then what will happen? They will break some of the hydrogen bond and break some of the hydrogen bond. Now, the ethanol molecules which were not escaping very easily because of the hydrogen bond, what will happen to them? On adding acetone, they will escape easily because some of the hydrogen bonds are broken. And when they will escape easily, they will form vapors easily. The vapors will have more pressure and then it will show positive deviation. Okay, so therefore, it shows positive deviation. So always in positive deviation, a funda ये रहेगा, there was some initial strong force of attraction present. Then some host के अंदर, host और guest के हिसाब से मान सकते हैं. For example, ethanol is the host where you are adding acetone. So host molecules, they had good intermolecular forces of attraction. They were attracted to each other. When you added something, that guest, it breaks some of the intermolecular forces of attraction. In this case, it was hydrogen bonding, and that is why it shows positive deviation. Okay, another example that we have to see is chloroform and acetone. Chloroform plus acetone. ठीक है, इस केस में देखिए जरा क्या होगा. When you have chloroform and acetone, then here you have to understand in terms of structure. ठीक है, neither chloroform is also polar, acetone is also polar. ठीक है, so we will write this point first of all. CHCl3 CH, CLP, and acetone both are polar. Now, when both are polar, we expected them to be ideal, maybe ideal type of solution, both are. But on mixing, they create, they form hydrogen bond. Now, hydrogen bonding, it arises from what? A very highly delta positive hydrogen, which is attracted by the lone pair electrons of some atom, of an electronegative element generally. Now, when we have chloroform, this acetone is something like this. Here we have oxygen atom, which is having lone pair electrons, and it is very electronegative. Then we have chloroform. The chloroform का आप इस तरह से देख सकते हैं, hydrogen that is connected to carbon, which is connected to 3 other chlorine. Now, hydrogen when bonded to carbon, it does not show hydrogen bonding. But when this hydrogen is connected to these chlorine atoms, then what will happen? These chlorines will be pulling electron density. It's very highly electronegative element, the chlorine also. Now, when 3 chlorines are present, then what will happen? They will pull too much electron density from the carbon and consequently from the hydrogen also. And this hydrogen will become extremely delta positive because of the effect of these 3 chlorines combined. And then what will happen? This always has a delta positive, but as soon as we add acetone, this delta positive hydrogen atom will interact with the lone pair of oxygen atom and form a hydrogen bonding link. So this hydrogen bonding was not present when we had only chloroform, because chloroform में oxygen नहीं है. As soon as you add acetone, which is having oxygen, it forms a hydrogen bond like this. Okay, and they form hydrogen bond. Therefore, it shows negative deviation. Okay, so copy this down. Raise your hand once you're done. Acetone or ethanol, chloroform and acetone. Please repeat these things, है ना? Whatever is done in the class, तो try कीजिएगा कि आप लोग repeat कर लिया करें. Waiting for Amna and Mariam. Just waiting for Mariam now. Take it. Now we have to see the graphs for Rawls law. Rather, graph for the deviations in Rawls law. Okay. Please write. Graphs for deviations in Rawls law. ग्राफ की अगर बात की जाए तो बहुत ज्यादा टफ ग्राफ नहीं, इसको बस समझना है आप लोग को, है ना? इट्स वेरी इजी टू मेक इफ यू नो द ग्राफ ऑफ रॉल्स लॉ. अगर आपको रॉल्स लॉ का ग्राफ पता है, रॉल्स लॉ का मैं समझा दिया था, आप उसी से समझ सकते हैं क्या द डेविएशंस आल्सो. ठीक है, सो डोंट वरी, अभी आप समझिएगा कि लिखने की जरूरत नहीं है आपको. ठीक है, now first of all, ignore the blue lines, just look at the dotted green lines. Just look at the dotted green lines in both of these graphs. दिख रहा है आप लोग को डॉटेड ग्रीन लाइन? yes or no please tell me guys. Insha, Mariam and Amna, you can see the dotted green lines, yes or no?
Yes.
So that dotted green line is ideal ना? देखिए जरा रॉल्स लॉ वाला जो ग्राफ बनाया था हमने. If you ignore the blue ones, imagine blue lines are not existing, then both of the graphs will be a graph for Rawls law. Make sense? yes or no please tell me. देखिए जरा.
Yes, sir.
ठीक है, उतना तो आपको आता है. ठीक है ना, उतना तो आपको आता है. पॉजिटिव डेविएशन में क्या होता है? वेपर प्रेशर बढ़ता है या घटता है? व्हाट हैपेंस टू द वेपर प्रेशर इन पॉजिटिव डेविएशन?
बढ़ता है.
बढ़ता है. देखिए जरा कौन सा होगा फिर, राइट वाला या लेफ्ट वाला होगा? ए और बी
Left.
पॉजिटिव डेविएशन
Left one, A.
A.
है ना, और नेगेटिव डेविएशन के
Yes.
लिए
B.
बी वाला, है ना. आई होप यू अंडरस्टूड. सारे प्रेशर बढ़ जा रहे हैं बिकॉज एज सुन एज वी, बट प्लीज अंडरस्टैंड द प्योर वेपर प्रेशर इट डज नॉट चेंज. Deviation occurs only in the solution. So as you are adding, things will change, है ना. वेपर प्रेशर बढ़ जाएगा दोनों का. एंड इन द केस ऑफ नेगेटिव डेविएशन वेपर प्रेशर दोनों का ही घट जाएगा. ठीक है ना. तो ये तो आपका सोल्यूशन क्या है, देखिए दिस लाइन, ये जो आपके पास लाइन है ना, दिस लाइन इट इज फॉर सोल्यूशन, और ये इंडिविजुअल कंपोनेंट्स के लिए, दीस आर फॉर इंडिविजुअल कंपोनेंट्स. ठीक है, तो ट्राई टू मेक दिस, और आप बनाते बनाते ही आपको समझ में आ जाएगा ना. यू कैन, इफ यू आइडेंटिफाइड इट देन यू विल बी इजीली अंडरस्टैंडिंग आल्सो. अब जहाँ पे P1 P2 लिखा हुआ है उसको हमारे अपने लैंग्वेज में क्या कहते हैं? वी कॉल इट PA एंड दिस विल बी PB. ये PB हो गया and this is very same PA, है ना. मोर फ्रैक्शन के लिए हम लोग A और B यूज करते हैं. A and B, A and B, A and B. A के लिए है, A के लिए है, ये B के लिए है. ठीक. The A graph is for positive deviation. ये किसके लिए? नेगेटिव डेविएशन. Raise your hand once you're done. Waiting for Amna and Mariam. Next topic, it is also an extension of the deviations in Rawls law. Okay. Now, please understand when we have, try to understand when we बात करना चाह रहे हैं. If we have extreme deviation, extreme positive deviation या extreme negative deviation from Rawls law. If you have extreme positive deviation from Rawls law, then what will happen? You will have too much vapors है ना, and boiling point of the solution, it will become very low. It will be lower than the solvent and it will be lower than the solute also. The other case will be when there is a negative deviation. In negative deviation, the vapor pressure is low, and since the vapor pressure is low, the boiling point will increase. And the boiling point will increase so much so that the boiling point will be greater than solvent and greater than solute also. Now these type of solutions, देखिए generally क्या होता है ना, ध्यान सुनिए जरा. Generally क्या होता है when we have a solution of A and B. Let's suppose A is boiling at 100 degrees Celsius and B boils at 240 degrees Celsius. Okay. Now, when we are going to heat it, when we are going to heat the system, then what do you think? Which will boil first, A or B? Which will boil first, A or B? Which will boil first, A or B? No idea. And if you start heating, which temperature will be reached first, 100 degree or 240 degree? बताइए. What, Insha?
A.
A ना, B क्यों कह? है ना, A 100 है, 100 पहले रीच करेगा ना. B क्यों कह रहे थे आप लोग? ठीक है. So what happens in this particular solution? A will start boiling. है ना? A will start boiling at what temperature? 100 degrees Celsius. Now, if you put a temperature, if you put a thermometer, the temperature of the system will not increase 100 degrees Celsius until and unless all the A is vaporized or boiled off because of latent heat of fusion. If you remember from 9th standard, after 100 degrees, you are still heating, but the temperature will not rise after 100 degrees Celsius. Why? Because whatever extra heat you are giving, it is getting used to convert the liquid to vapor. याद आया आप लोग को लेटेंट हीट ऑफ कन्वर्जन, लेटेंट हीट ऑफ फ्यूजन, ये सब ऑफिशियल में आमना मरियम इंशा इतना कुछ पढ़ा था आप लोगों ने 9th स्टैंडर्ड में? नहीं पढ़ा था? आमना मरियम एंड इंशा. Just give me a second. You have not heard of this term, latent heat of fusion? Amna, Insha, and Mariam?
No, sir.
No, अच्छा ठीक है. अभी आप लोग बता चलेंगे 9th स्टैंडर्ड में पढ़ाया जाता है वैसे?
Sir, 9th was online.
Ninth.
ठीक. 9th आप लोग का, हाँ 9th कोरोना. 9th
हाँ
कोरोना
तो
में आप लोग?
yes sir. हाँ sir.
9th.
बस लास्ट का थोड़ा सा
हाँ.
टाइम was offline.
ठीक ठीक. चलिए, तो whatever extra heat you are going to give ना, वो कहाँ पे यूज होगा? It will be used for conversion from liquid to vapor, because liquid molecules will be attracted. Vapor बनाने के लिए उनको दूर ले जाना पड़ेगा, right? तो उस दूर ले जाने के लिए इसमें यूज होता है, that energy is getting used. 100 degrees Celsius के बाद ना, it will not increase at all. Once all the A particles have boiled off, it has vaporized, then what will happen? Then the temperature will start increasing. Now this is one of the ways of purification also. Like if you want to separate A and B, then what you will do? If they have a difference, a quite huge difference in temperature, then you can use distillation. Distillation इसी पे काम करता है. Okay, so in this distillation, what happens? First of all, you boil off A, and then you have to capture A also. No, पूरा अगर बताएं, hope you remember distillation somewhat. Now, suppose this is इस तरह से कुछ आएगा यहाँ पे, है ना? Here we have stopped it. So A is boiling off, and we are capturing the A here, and then in this container we have some very cold liquids. So the vapors of A will travel here, and they will come down, and they will drop wise get collected somewhere here. Okay, I have made very bad diagram, but I hope you understand. This is how distillation also works. But what in cases of extreme deviation, what happens? A and B are repelled. A का 100 degree Celsius है, B का 240 degree Celsius है. But in the solution, A and B are repelling so much so that both A and both B, they will evaporate at 80 degree Celsius itself. जो boiling 100 पे होना था only A को, but they are repelling so much, they are repelling each other so much that the solution will boil off at 80 degree Celsius itself. That will be the case of positive deviation. Now the other case would be A was boiling at 100 degree Celsius, B was boiling at 240 degree Celsius, है ना? And they have, when A was only having intermolecular force of attraction between AA molecules, B का BB के साथ था. Now when you are going to mix them, there is new intermolecular force of attraction between A and B that is very strong, and that is so strong, that the solution will now boil at 250 degrees Celsius. 100 degrees Celsius boiling क्यों नहीं कर रहा है? Because A is attracted by B. नीचे A and A का interaction उतना ज्यादा अच्छा नहीं है, but when A and B mix, A and B have very good interaction. That is why at 100 degrees Celsius, why A is not boiling? Because B is holding that A back. B hold करके रख रहा है A को. ठीक है? So these are the two deviations in this type of solutions. The solution will boil at constant temperature. Generally, a solution will boil at two different temperatures. First temperature will be of lower boiling point. Another temperature will be of higher boiling point. है ना? A और B का solution है. Ideally, boil कैसे होना चाहिए? एक बार 100 डिग्री सेल्सियस पे and दूसरी बार 240 डिग्री सेल्सियस पे, right? Ideally. But when you have extreme deviations, the solution will boil at a constant temperature. And these type of solutions are known as azeotrophs. समझ में आया थोड़ा बहुत आप लोग को? हाँ या ना बताएं?
Yes, sir.
ठीक है, चलिए. Moving on. You will write it down. ठीक है. Azeotrophs. What are azeotrophs? Solution or rather solutions which boil at constant temperature. At constant temperature. Another thing, azeotrophs have same composition in liquid phase as well as vapor phase. As well as vapor phase. क्या मतलब है इसका? लिक्विड फेज में भी आपके पास क्या होगा? ए एंड बी, और उसी तरह से आपके पास ए बी दोनों ही निकलेगा वेपर फेज में. ऐसा नहीं कि ए पहले निकला बाद में बी निकल रहा है. Is everyone done? I'm just waiting for you. ठीक. Now, अब azeotrophs को भी ना दो हम लोग डिफरेंट कैटेगरीज में बांट. One will be known as maximum boiling azeotroph. Maximum boiling azeotroph. दूसरा होता है मिनिमम बॉइलिंग azeotroph. मिनिमम बॉइलिंग azeotroph. ठीक है, यहाँ पे क्या होगा? In this, boiling point of solution is greater than the boiling point of both components. Boiling point of solution is greater than boiling point of both components. Next is shown by. This type of deviation is shown by solutions with negative deviation from those. This will be boiling point of solution is lesser than boiling point of both components. Okay, this is shown by solutions with positive deviation from Raoult's law. After this down, raise your hand once you're done. I'm sorry, guys. I don't know how I got disconnected. All of you done writing is unofficially?
Yes, sir.
ठीक है. अब कुछ सवाल हम लोग देख लेते हैं. The questions are completely factual, है ना? Whatever we have learned till now. इसी के basis पे positive deviation, negative deviation पर. Like they will ask which of the following is true for ideal solution, considering delta H is equal to negative positive 0 plus, है ना? Those type of questions इसके लिए सकते हैं. ठीक है, तो डायरेक्टली आपको इस तरह से सवाल आ सकता है. Which of the following will form an ideal solution? बताइए जरा. You can use your notebook. लेकिन जल्दी बताइएगा जरा, है ना? You can use your notebook.
N-hexane and N-heptane, option
हाँ,
C.
C, ऑप्शन सी, राइट, बिल्कुल एकदम ऐसे ही सवाल आएंगे। इसी तरह से मान लीजिए आपके पास एक और सवाल है। आई एम गिविंग यू अ लिस्ट ऑफ क्वेश्चन, बट ये सारे क्वेश्चन आपको करने की भी जरूरत नहीं है। विल गिव सम ऑफ देम इन द होमवर्क, है ना? अभी देखिए जरा, एक ऑल ऑफ दीस आर व्हाट। ये पहला वाला सवाल बस आप कीजिए, 27 नंबर, ऑन मिक्सिंग 20 ml ऑफ एसीटोन एंड 30 ml ऑफ क्लोरोफॉर्म। वॉल्यूम जो होगा क्या होगा उसका, क्लोरोफॉर्म और एसीटोन का। यू शुड रिमेंबर दैट क्लोरोफॉर्म एंड एसीटोन ये किस तरह का डेविएशन दिखाता है, पॉजिटिव और नेगेटिव, एंड देन ओनली यू विल बी एबल टू आंसर दिस। एबीसीडी आंसर कीजिएगा चैट में प्लीज, एबीसीडी इन द चैट। ओके, व्हाट अबाउट अदर्स? बाकी लोग आंसर नहीं कर पा रहे हैं? इंशा ने आंसर किया, जल्दी बताएं बाकी लोग। आमना एंड मरियम। ओके आमना, मरियम, व्हाट अबाउट यू? First of all, you will identify chloroform or acetone, what deviation? Mariam, chloroform and acetone, they will show what deviation, positive or negative? बताइए मरियम। मरियम, मरियम हम क्या पूछ रहे हैं आपसे?
Yes, sir.
ये बताइए, एसीटोन और क्लोरोफॉर्म को मिक्स करेंगे तो पॉजिटिव डेविएशन होगा या नेगेटिव डेविएशन होगा? नोटबुक में देख के बताइए ना, हमने किया है एसीटोन और
Negative.
क्लोरोफॉर्म। नेगेटिव डेविएशन, नेगेटिव डेविएशन में देखिए वॉल्यूम क्या होता है, वी मिक्स क्या है, व्हाट इज
It
द
will
वी मिक्स?
decrease.
हाँ, तो डिक्रीज होगा ना, तो होना चाहिए 50, लेकिन होगा 50 से कम। ऑप्शन नंबर ए मेक सेंस।
Yes. Okay.
ठीक है, देखिए 28, व्हाट हैपेंस व्हेन एसीटोन इज एडेड टू प्योर इथेनॉल? आपके नोटबुक में है आंसर, इथेनॉल प्लस एसीटोन लिखा हुआ है ना?
Yes, sir.
बोलो, है ना? लिखा है हमने, दोनों लिखा है, एसीटोन और इथेनॉल, और क्लोरोफॉर्म, और ये भी लिखा है, देखिए क्लोरोफॉर्म प्लस एसीटोन, इथेनॉल प्लस एसीटोन, ठीक है, दोनों लिखा हुआ है, तो ये लिख देना है बस आपको, ठीक है। देन यू हैव,
Yes.
देखिए नेक्स्ट है आपके पास, what type of deviation from water is observed by mixing chloroform or acetone? Why is a decrease in vapor pressure observed mixing chloroform and acetone? जो हमने लिखा है बिल्कुल उसी को लिख दीजिएगा, आंसर मिल जाएगा आपको, और वो फोटो बना दीजिएगा, ठीक है ना? उसके बाद फोटो बना दीजिएगा। राइट टू डिफरेंसेस बिटवीन आइडियल सोल्यूशन, नॉन आइडियल सोल्यूशन। आइडियल सोल्यूशन फॉलोज रॉल्स, नॉन आइडियल सोल्यूशन डज नॉट फॉलो रॉल्स लॉ, ठीक है? उसमें फिर बता दीजिएगा कि नॉन आइडियल सोल्यूशन के अंदर एक एग्जांपल दे दीजिएगा, एक तो ये डिफरेंस हो जाएगा, और एक डिफरेंस लिखने के लिए व्हाट यू कैन डू, यू कैन टॉक अबाउट द डेल्टा एच। तो डेल्टा एच विल बी इक्वल टू जीरो, नॉन आइडियल में डेल्टा एच विल नॉट बी इक्वल टू जीरो, आइदर पॉजिटिव होगा या तो फिर नेगेटिव होगा, ठीक है? डेल्टा वी विल बी इक्वल टू जीरो इन आइडियल, नॉन आइडियल में डेल्टा वी या तो पॉजिटिव होगा, नेगेटिव होगा, जीरो नहीं होगा, ओके? व्हाट इज मेंट बाय पॉजिटिव डेविएशन? गिव एन एग्जांपल, व्हाट इज द साइन ऑफ डेल्टा एच में कराया हुआ है ना, नेगेटिव डेविएशन। व्हाट टाइप ऑफ डेविएशन इज शोन बाय मिक्सचर ऑफ इथेनॉल एंड एसीटोन, ठीक है? सो ऑल ऑफ दीस क्वेश्चंस आर देयर इन योर नोटबुक, है ना? बिल्कुल आराम से आप इसके बारे में, मतलब जो कुछ लिखा है हमने उसी को लिख दीजिएगा, आंसर मिल जाएगा। इट इज नॉट इन द, लेकिन इट इज नॉट इन द फॉर्म ऑफ अ क्वेश्चन, but it is in the form of notes। अब उसी तरह देखिए एजियोट्रोप्स, ठीक है? एजियोट्रोप से सवाल रिसेंटली आया है, लेकिन एजियोट्रोपिक सॉल्यूशन ऑफ टू लिक्विड हैज बॉइलिंग पॉइंट लोअर देन आइदर ऑफ द टू, तो ये पॉजिटिव डेविएशन शो करेगा या नेगेटिव डेविएशन, या फिर कुछ नहीं शो करेगा। इन नॉन आइडियल सॉल्यूशन व्हाट टाइप ऑफ डेविएशन शोज the formation of maximum boiling azeotrope? Some liquids on mixing form azeotrope. What are azeotropes? Define azeotrope. what type of azeotropic mixture will be formed by solution of acetone and chloroform. Acetone and chloroform negative deviation, तो maximum boiling. Justify on the basis of strength of intermolecular forces of interaction. तो वही एसीटोन क्लोरोफॉर्म में जो हमने लिखा है ना उसी को लिख दीजिएगा, और वहां से फिर आप एजियोट्रोप को मिक्स कर दीजिएगा. एजियोट्रोप यहाँ पे कैसा फॉर्म होगा, मैक्सिमम बॉइलिंग वाला एजियोट्रोप. ठीक है, एक बार रीड कर लीजिए सवालों को. आई होप इट विल मेक सेंस. These are all the questions that has been asked in this topic. ठीक है, तो लास्ट 10 years में जितने भी सवाल थे ना सारे हमने यहाँ पे एंड देयर इज नॉट अ सिंगल एक एक ही दिन मतलब 2021 और देखते हैं डिफरेंशिएट. अब ये जैसे हमने सवाल नहीं लिया था ये वाला, बिकॉज दिस इज द मिक्स क्वेश्चन. इसमें दो टॉपिक मिक्स है, बट यू कैन सी दैट डिफरेंशिएट बिटवीन आइडियल सॉल्यूशन नॉन आइडियल सॉल्यूशन. ये 2023 का हो गया ना, 2023 हो गया. और फिर आपके पास 2021-22 में आया है, 2020 में आया है, देन 2020, 2019, 2017, 2015, 2014. लाइक एवरी ईयर यू विल हैव एटलीस्ट वन क्वेश्चन फ्रॉम दिस पर्टिकुलर टॉपिक. एक सवाल तो जरूर ब जरूर आपको इस पर्टिकुलर टॉपिक से मिल जाएगा. ठीक है, चलिए. ऑल ऑफ यू अंडरस्टूड दिस? यस और नो प्लीज टेल मी. देखिए आपने सवालों को, हाँ या ना बताएं.